2. So I'm just going to recap basically everything we've gone through so far. So if you remember about the first thing we went over was the fundamentals of organic chemistry and methane, which is the simplest organic compound. So if you remember, organic chemistry is the study of hydrocarbons, which is compounds with just carbon and hydrogen and their derivatives. And the key takeaways for that section is carbon is tetravalent, which means it always has to have 4 bonds to be stable. So in all organic compounds, carbon has to have 4 bonds. Methane is tetrahedral, as you can see right here, and is also sp3 hybridized, which tetrahedral and sp3 hybridized, those are pretty synonymous. You can use those interchangeably. And methane has 2 bonds. These ones right here that are coplanar. We have 1 bond in the back going behind the plane and 1 in the front, is shown by a wedge. So our carbon-hydrogen bonds are formed by the overlap of the sp3 orbital of carbon and the 1s orbital of hydrogen. That's how all these bonds are formed. And carbon-to-carbon bonds are formed by the overlap of both of their sp3 orbitals. Okay, so we also went through, there's several different ways to show organic compounds. Over here you see molecular formulas. They're not very helpful. They don't tell us a lot of information besides just what's in the compound. We can also have a 3D structure, as you see right here. I couldn't find one for heptane, but just pretend that looks like all the rest of them. But so as you can see, all these carbons, they have 2 bonds, coplanar, right? 1 that's in the back and 1 that's in the front. So we also have structural formulas. I highlighted the condensed structural formula, which is a bit easier than writing out all the bonds. That's probably what you're going to see most often, if not line structures. So if you remember line structures, all of these points represent carbons. So we have 1, 2, 3, 4, 5 carbons, as you see right there. And all the lines represent carbon-to-carbon bonds. And if you'll remember that all the carbons have to have 4 bonds, but in these line structures, only 2 are shown. So, yes, sorry, Jemima. So, as you can see, that the other bonds that aren't shown, we can assume to be carbon-hydrogen bonds, and the same for all of these. Okay, so the next thing we went over was alkanes, which are organic compounds where all the CC bonds are single bonds, which are also called sigma bonds. Here are all your prefixes for however many number of carbons you have, and the suffix for alkanes is ane. So we have methane, ethane, propane, and so forth. And you're only required to know up to 8 carbons, but there are more after that. And the formula for alkanes is CnH2n plus 2, where N is the number of carbon atoms. So, and then we also went over alkyl groups, which are just incomplete groups that are formed from removing 1 hydrogen from an alkane. And we use capital R to represent these sometimes. So if you ever see an R, that just means some alkyl group. So as you can see with the methyl group, this suffix YL means an incomplete alkyl group. This is just formed by removing 1 hydrogen from methane, and that frees up this carbon to make another bond with something else. And same with ethyl, we removed 1 hydrogen from either carbon, because these are the same, and that frees that carbon up to make another bond with something else. So past 2 carbons, you start getting into isomers, because all of these can have different structures and different isomers. So we have to pay attention to the classification of carbons, right? So primary carbon is defined as a carbon that's connected to 1 other carbon. So that'd be like this one right here on N-propyl, because it's connected to 1 other carbon. And we have secondary carbons, like this one right here. It's connected to 2 other carbons. That's why this is called secondary butyl. And we have tertiary carbons, which are connected to 3 other carbons down here. So as I said, we have past 2 carbons. You have to start clarifying that this is a straight chain. So we have the N here for propyl, right? But we can also have isopropyl if we remove a hydrogen from this middle carbon. So here's isopropyl down here. I'm sure you've heard of isopropyl alcohol. That has just an alcohol with an isopropyl group on it, right? So our 4-carbon alkyl groups, we can have N-butyl, yes.
So anything, can you explain like which one has an N in front of it?
Yes, so for incomplete alkyl groups, you have to start putting the N in front of it at 3 carbons because you have these 2 different options. So you have to clarify that this straight chain is normal propyl, right? Because you can either have normal propyl or isopropyl. But for alkanes, you start at 4 carbons because for just alkanes, you can just have propane. You can't have isopropane. If they're complete for 3 carbons, you don't have to put the N. Because for propane, I can use this. I'll try to draw it. So for, that is ugly, but okay. So for propane, you don't have to put that it's N-propane because there's no other options to what this could be. You can't rearrange the atoms in a different way that it's not in a straight chain. Does that make sense? But when you take a hydrogen off, you can either take one off from here or you can take one off from the middle. So that's why there's 2 different options, but there's not that option when it's just a alkane. Does that make sense? Okay. So back to the 4-chain or the 4-carbon alkyl groups, we can have N-butyl, which is just your straight chain, which is when we take a carbon or a hydrogen off of a terminal carbon, which is just a carbon at the ends. We can have secondary butyl or sec-butyl, which is when we take a hydrogen off of the 2nd carbon, which is a secondary carbon, which is connected to 2 other carbons. We can have isobutyl, which, if you remember, follows that general rule for iso somethings, where we have a carbon chain, and then we have 2 methyl groups on the end, right? So that follows that general rule. And we can also have tertiary butyl or T-butyl or tert-butyl, which is the incomplete carbon is a tertiary carbon, right? Okay. So as you see, now we get into isomers. So we have structural or constitutional isomers, which are when compounds have the same molecular formula but different atomic connectivity. So as I said, after propane, N is required before straight chain alkanes, just so you can differentiate between the isomers. Okay, so I have a bit of an example I wanted to go through here for C7H16. So we know that's an alkane, right? Because it follows.
This is one of your homework questions. Have you done that?
It is. Do you want me to still go over it, or you want me?
It's up to you. I just remind you.
It is. I didn't know that. My bad. I'll only do like half of them, so I won't ruin your whole homework, because I know you guys would hate that. Okay, so your first one, right, is going to be your straight chain alkane. This is so ugly. I'm so sorry. Just
Very difficult.
it's so hard to write on this. Just pretend that this is, yeah. Okay, so that's our first one. It's just straight chain heptane. So this is N-heptane, right? It's a straight chain.
The letters or the numbers on the first and last.
Yes, those are 3s. My bad. The first and the last one are supposed to be 3s. Okay, so a good way to do problems like this is to start with your straight chain alkane, and then from there you can take one hydrogen or one carbon off of the chain and then find all your isomers for that chain. So I would take one off and then find all my isomers of hexane derivatives. So if I take one carbon off here and then figure out where I can put it on here, I can make however many isomers. So I could put a methyl group here, right, to make my first isomer. Okay, and that's one. So I'm going to go over naming in a second, but does anyone want to take a stab at what that's called? Technically, yes, but we're going for IUPAC names. That is technically iso or isohexane, right?
Heptane?
Yeah, or heptane.
As-heptane?
So, okay, we'll go over naming in a second, but this is a methyl group, right? And this is my carbon chain. Yeah.
Okay.
We're getting there. Okay, so, and my methyl group is on my second carbon, so I have 2 methyl hexane. Does that make sense?
Yes.
Okay. So I can also move this. I can move this here to this carbon, right? To the next one. I did not anticipate my handwriting being this ugly. I'm so sorry.
It's very
I really thought it would be easier than this. Okay. So, and what would this one be called? This is a methyl group right here.
3 methyl.
Right. Yes. And when you're doing problems like these, you always want to double check to see if you're not, to make sure you're not making just the same compound, because it can look different but be the same compound. So these are different, right? But you see, if I moved this methyl group to this carbon, it'd be the same, because I could just count it from the other way. So you always want to make sure, be careful that you're not doing that. So that's all the options I have for hexane derivatives. So now I can go down to my pentane derivatives. So I have a few options, right? I can have 2 methyl groups on various carbons, or I can have an ethyl group, right? So I can have my 2 methyl groups on the same carbon, on the second carbon. Do we know what this one was we called? If you can tell what that even is.
Dimethyl hexane. Wait,
Close.
1,1-dimethyl pentane.
It'd be 2,2. This is your second carbon. Yeah, because there's the carbon right here. There's a 2,2. Dimethyl pentane. Oh my gosh, why is this so hard? Okay, that's this dimethyl pentane. Just if you were wondering.
Is that CH2 on the top of the carbon and then CH2?
These are both CH3. These are both methyl groups,
Okay.
and this is CH3. That's CH2, CH2, and CH3. Okay. I won't go through the rest of these just because it's on your homework, but as you can imagine, that's true. But I'll let you figure it out. Go ahead. The rest of these are easy because you can move these 2 groups here on this carbon, and that'd be different on this next carbon. Or you could have one here and one here, and that'd be different. or you can have an ethyl group in the middle. But I'll let you figure that out. Does that make sense? Okay. So the next thing we focused on was naming alkanes. So I have a few examples here. So your first step is always finding the longest carbon chain, which is going to be your parent compound. Your next step is numbering the chain starting from the end that's closest to that first side group. Your next step is name and assign positions to all of the side groups. And when you're listing names, you can indicate identical groups with the prefixes di, tri, tetra, all that stuff. And then you're going to list side groups in alphabetical order before the parent compound and include the position number. So I have a few examples I wanted to go through with you guys. So as you know, when you're doing problems like this, it's tempting to say that this is your longest chain and that's your parent compound. Is it? No, because that'd be too easy. This should be just 1H, my bad. Okay, so again, you have 1, 2, 3, 4, 5, 6 carbons here, right? But what if I included this one? I have 1, 2, 3, 4, 5, 6, 7. So that would be my parent compound and my longest chain. Cooler. Okay, so my next step is to start numbering the chain. So I can either start from the left end or the right. I'm going to start at the right because it's closest to, get another color. It's closest to this.
3-methylheptane. 3-methylheptane.
Yes, but we're getting there. Okay, so it's closest to this first side group. This is 1, 2, 3, 4, 5, 6, 7. Okay, so our longest chain is 7 carbons long. So our parent compound is heptane, right? Okay, but I have a methyl group right here, and it's on carbon 3. And there's just one, so I don't need any prefixes. So it's going to be 3-methylheptane, right? We feel good about that? Okay. So this next one, it's a little bit harder. Nothing too bad once you break it down. So again, you might be tempted to say that this is the longest chain. It almost never is because that is too easy. Okay, so this one has 1, 2, 3, 4, 5, 6. But what if I start from this end? I go 1, 2, 3, 4, 5, 6, still 6. But what if I start from this one? I have 1, 2, 3, 4, 5, 6, 7. Okay, so that would be our longest chain.
So you just have to count it from every start to see the long.
Yeah, I mean, you would have to just check and make sure that there's not a longer chain. So you can start counting from wherever side group or whatever terminal carbon.
From the side group, you can only go one way on that straight chain. Like you don't count one, but
Yeah. So when you're counting an unbroken chain, so I have 1, 2, 3, 4, 5, 6. Like if I start counting from this side group, then this becomes a side group, right? Okay. So we said that this is our carbon chain. So our side groups are here, here, and here. So I'm going to start counting on the end that's closest to my first side group, which is going to be this bottom one right here. I have 1, 2, 3, 4, 5, 6, 7. So my parent compound, my longest chain, is 7 carbons long. So again, my parent compound is going to be heptane. Okay, So now we're going to name and assign positions to all our side groups. So this one right here, we know that's methyl, right? And it's on carbon 2. Do you remember what this one's called? Right. It's on carbon 3. How about this one? There's 3 carbons. Is it N-propyl though?
No, it's
Isopropyl, right? Because I have these 2 methyl groups here. If this one was, if this was like here and it was just 3 carbons in a chain, it'd be N-propyl, right? But because this is branched, then it's isopropyl. Okay, so now we can start actually naming. So which one goes first? Fluoro, right? And it's on carbon 3, so I have 3 fluoro. That is so ugly. It says 3 fluoro, I promise. Okay, and then what goes next?
4 isopropyl.
Right. I'll reiterate in a second, I'm sorry. Okay, and then we have dash. And our methyl group is on 2, right? 2 methyl heptane. Okay. So to reiterate, that says 3 fluoro, 4 isopropyl, 2 methyl heptane. Do we all get that?
Is there, like, between 3 fluoro and 4 isopropyl?
Those are dashes, yeah.
There's a dash between that.
Yes, so you separate numbers from numbers with commas, but numbers from words with dashes.
Okay.
Okay, so there's a dash between 3 and fluoro and 4 and 4 and isopropyl and 2 and 2 and methyl. Does that make sense? Yes.
Why do you have, which way do you decide to like start counting from?
Okay.
Do you start at that top one and count the other way?
So if I started from this end, our goal is to have the lowest numbers possible. So if I start counting from this end, I wouldn't hit my first group until 1, 2, 3, 4 carbons. But this end is closer to this first side group.
So you want to count the direction that you hit your first.
Yeah, you start counting when on the end that's closest to your first group, so you can get the lowest numbers. Because if I started from this end, then my numbers would be 4, 5, and 6 instead of 2, 3, and 4. Does that make sense?
For the numbers from the bottom, it's like 3 fluoro, so you count the same direction that way too.
What do you mean?
Because a 3 in front of the fluoro.
Okay.
You count that way.
Yeah, so these are in alphabetical order, right? And not in numerical order. So I started with fluoro because that comes first in the alphabet, and that's just on.
Yeah, no, I was asking
Yes.
why you put the 3 instead of 2.
Does that? Okay. Do you mean why did I?
We're good.
Okay, are you good? Are you sure? Okay. Okay. So this one's a little complicated, but it's good practice. Okay, so our first step is, again, we just find our longest chain. So we can try, just start counting somewhere and see where it gets you. So right here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons here. What if I start from here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's a bit bigger. But if I go down here, I have 1, 2, 3, 4. I should use the pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So And I can check and make sure that's our longest chain. So 1, 2, 3, 4, 5, 6, 7. It's not as long as 10. 1, 2, 3, 4, 5, 6, 7, 8. So I can be sure that this is my longest chain. Okay. All right. So now that we've done that, oops. Shoot. So I can identify my side groups. So I have 2 methyl groups right here. I have this group, this one, and this one, right? 'Cause these are all branching off this big parent compound. Okay? So which end am I going to start counting on? Left or the right? Left, right. Right, Jemima. The chain does not have to be a straight line. It just has to be an unbroken chain of carbon. So we're going to start from the left, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you don't have to know what that's called because we only have to know up to 8, but 10 carbon chain is called decane. Okay, so my parent compound is decane. Okay, so now I can name and assign positions to all my groups. Okay, so we know what these are, right? They're methyl groups. And which carbons are they on? 3 and 4, right. And there's 2 of them, so I'm going to have to use the prefix di. Okay. And right here, yeah, those are 2 ethyl groups. Yeah, there's chloro in the middle. Yeah, but I have 2 ethyl groups on C5 and C7. Yeah, so I'm going to have to say diethyl when I write down the name. And then this one is chloro, right? Also on C7. And then I have this group down here. What's this called? Propyl. But remember, I have to put that N in front of it, right? Because it's a straight chain. Okay. So now I can start writing stuff down. So which one's going to go first? Chloro. Chloro, right? C. Okay, so I have 7 chloro. I'm going to separate that with a dash. And then next I have ethyl. And remember, we don't consider prefixes when we're ordering things alphabetically. So these are both start with a D technically, but we only pay attention to ethyl and methyl. So ethyl comes first. So I have 5 and 7 diethyl. And remember, you separate numbers with commas. Okay. And my next one.
3, 4 down ethyl.
Mm-hmm. Okay, and then my last group is going to be 5 and propyl. And my parent compound is decane. Does that make sense? Got that? Okay. So before I open up to any questions, somebody did ask me if I would go over your lab, what to put in your lab notebooks and how the exams are going to be. This morning, yes, I will, Jemima, in just 1 second. So this morning we decided that we were going to do the email tests again. So on whatever day your test is, he's going to email you a copy of the test. You can either print it out and do it and scan it, send it back, or do it on whatever software you have if you can write on it. Your lab notebooks. So what you want in your lab notebooks, you want the title of the lab, you want the purpose, which is going to be in your, what's it called? Yes, the lab manual, or if not, then Dr. Sun will tell you. You need your principles, which is where you can put the mechanism for the reaction if there is one. You can take notes on the pre-lab lecture and principles, things like that. And then you have your raw data, which is where you're going to put, you know, if you had 6.2 grams of whatever you just made, that's where you'd put that, is in your raw data. Okay, so Jemima asked if I could go back and explain that. I don't have it written down anymore because it deletes it. Okay, so I'll rewrite it.
Would that be like a question on the test since it's above the 8 we need to know?
No, I just put that, it's just good practice just to get it as complicated as possible. But yeah, you're only required to go up to 8. Okay, so we said this is our longest chain, right? And then we had our side groups. So the name was, what did I say? We have 7 chloro because we started counting from this carbon over here. We have 7 chloro because that chloro group right here is on C7. And then I have 5, 7, or that's supposed to be a comma, my bad. 5, 7 diethyl, because I have 2 ethyl groups on C5 and C7. And then it was 3, 4 dimethyl. Because I have 2 methyl groups on C3 and C4, and then 5 N-propyl, because I have that N-propyl group on C5, propyl decane. Does that make sense, Jemima? I'm so bad at writing on this. Yes?
Vivian, if you have to write many words, you can use the writing function, T.
That makes sense. That would be a lot easier. Now I know that. Thank you. Okay. Yeah, I really didn't anticipate writing on this to be that hard. I don't know how you do it so well. Okay. Does anyone else have any other questions?
Could you, it doesn't have to be like a long one, but I get confused whenever there is like, how do I put this? Like, there's a subscript, so like there's more than one of them, like how you draw it. So like, hold on, I'm
Yeah,
gonna just write
come to
something. Like, if it was like if it was like this, something simple, but I get confused whenever I go to write it, like whenever they put it in parentheses and that, yeah.
Yeah, so she asked like, oh, right. Okay, right here. So if you have something like this, how do you know what it looks like? Okay, so from this you can tell that we have 1 carbon here, right? Okay. And it doesn't have any hydrogen, okay? And we have 2 CH3, which are methyl groups, okay? So, I mean, by default, you would have to have 2 other bonds here. But just from like what
Right.
that says, that's what it would look like.
Okay.
So if there's something like with a subscript here,
Right.
then that means that that is connected
So
to
there,
this.
yeah, I guess that was my question, because it was a big long chain, I just remember that was like in it. So they're only connected to like that.
Okay, wait, are you talking about like, if there's like, that?
Right.
Okay, so that just means that it's a big, long, straight chain, okay, but you didn't want to write out CH2 that many times.
Okay.
Okay, so that's a way to condense it even further. Okay, so that would be a, however many, 9 carbon chain.
Right.
Does that make sense?
Yeah.
Okay. All right, then Jemima asked, do you consider the N when writing alphabetically? Yes, you do, right? Yes, you do consider the N when you're writing alphabetically.
For the, for any problem, right?
Mm-hmm.
No. So-
No, you don't. Just kidding. Okay.
You don't, so that doesn't matter in the alphabetical order?
No. Right. So if you have like an N like pentyl group, that doesn't.
So N and di don't matter, it's just like the actual name.
Yes.
Yeah, you're right, you're right. But
Okay.
The prefix, bi, what's that? Bi, tri, tetral, pentant. For those things, you don't count for the alphabetic one.
What about N and ISAM? Do you count those?
Oh, that's right, you have to count that.
Okay.
You're right.
Yes.
In method, you're right, you're right.
Okay. So if it's like N-propyl or isopropyl, you do have to count that
Yeah.
in. Okay. Okay.
Okay.
All right. Any other questions, my friends?
Can you send it PowerPoint this?
I can. Yeah,
Thank you.
I will do that.
I'm sorry, I'm confused. In an isopropyl, you have to count the iso as being an alphabet.
Mhm. Yeah. So I had that on one of those.
You would alphabetize by the I, not the P,
Mhm.
or
Really?
N and not the P.
Yeah.
The only thing it doesn't count is the prefix, like bi, tri, tetral, pentant.
Okay. If you guys don't have any other questions, then I don't have anything else.
You know, you can download the recording, right?
Yes. Make a proposal, Jemima.
You can also download the recording of my lecture.
Except for this one. There's a number in front of him. Okay. Dr. Sun said no.
Way to think outside the box.
Haley said yes. Everybody in the room says yes except for Dr.
That's a tall order, my friend. The exams are not that bad, I promise. They're okay.
Usually the questions about exams go to me.
Yeah.
Questions about the chemistry
Yeah.
go to you.
The exams aren't that bad, I promise. You'll do fine.
Okay, now all I need is for you to fast forward, take micro, and then also BRTA.
I don't have to take micro
I know.
because I don't like biology, but you're all fine.
Wait, you guys don't have micro TA?
No, it's a 300 class.
Yeah.
Oh, yeah. It's not that bad. Do you want to BRTA?
Fun fact, they don't pay for TAs above freshman level classes.
I know. Well,
Yeah.
but see, for zoology, the department decided to pay for the TA. If they're, because.
Yeah, if they had money, but alas,
They do
chemistry.
the same for E and P, but
Yeah.
for some reason A and P does not like have one.
We can-
He doesn't have points in the micro.
Yeah.
my TA, created a bunch of Quizlets for, micro, so I can see if I can find them.
Girl,
Send them my way.
Okay.
Send them my way.
And we can have a group chat if you guys want. Would you guys like that?
yeah.
Okay. You can just like email me your numbers and I can make a group me if you want to do that. I can announce that on like Friday, if that sounds good. That'd be a lot easier than me trying to email you guys all the time. Okay, yeah, I'll do that on Friday.
Thank you, Lydia.
You're so welcome. I don't have anything else, so you're free to go. You're welcome.
The best is.
Thank you.